Okay, so Miss Hall and I decided that we would this week do videos that we record to see if that maybe helps y'all out a little bit more. So we're going to do law of sines and law of cosines. We're going to be solving non-right triangles. So today we're just going to do simple law of sines. Wednesday you'll get a video with the ambiguous case of the law of sines, and then Friday we'll do the law of cosines. So you're going to use law of sines, law of cosines, depending on what information you're given. We'll get into that on the next slide. This slide is really just to say here is the law of sines. There are two versions, but it's the same thing. You see how one's just the reciprocal of the other? You can use either one of them all the time. It's just if you're looking for an angle, it's easier because your angles are on top here. If you're looking for a side, it's easier because your sides are on top here. So again, I tend to use this one because you can use either one all the time. It's just one is a little faster, I guess, than the other one. Some more basic info is just remember that when you are labeling a triangle, we use capital letters for angles, lowercase letters for sides, and matching letters are across from each other. So angle C is here, so side C is here. Okay, so again, just some more information. Remember, you can pause and read. I'm going to go through kind of quickly what this is saying. So why are there three parts to the equation? Well, it's really just setting up three ratios that are always equal. So when you're solving using the law of sines, you're going to pick the two ratios that you need for that particular problem. If you want to see a proof of where the law of sines comes from, you can look in your textbook. I think that is page 459. Here, let me make sure I'm not lying to you. Yes, page 459. If you have your textbook at home, you can see the proof there. You can Google the proof of the law of sines if you want to see it, or you can email Miss Hall or I, and we will kind of explain it to you if it's important to you. Anyway, why are there two different forms? So I just talked about that on the last slide. It's whether you're wanting to find an angle or a side. You can pick the form where what you want is on top because it's just reciprocals of the fractions. What if we don't have ABC as the angles in our triangle? Well, that's okay. Just replace the letters accordingly. And then when do you use the law of sines? Well, if I'm asking you to find a missing piece of a triangle or solve a triangle, then you can use law of sines if you have angle, angle, side, or angle, side, angle. All right, two angles and a side, because you can only have one triangle with two angles and a side. You'll learn in the next video on Wednesday about how two triangles might be possible. That's why it's called the ambiguous case of the law of sines. Okay, before today, everything is going to stay nice and simple. So using that law of sines formula, if you see here, we're looking for side C. So I can say C over sine of the angle opposite that side, so 105, is equal to, and then we know 35 degrees, so we're going to go the side opposite that, 7 over sine of 35 degrees. All right, so you have a fraction equal to a fraction, also known as a proportion, which y'all have been solving since middle school. So you know that you cross multiply. So you're going to have C times the sine of 35 degrees is equal to 7 times the sine of 105 degrees. We're solving for C, so we're going to divide by that sine of 35 on both sides. Y'all, I'm going to tell you exactly what I'm doing. I may not write every little step down because, as you can tell, it's a struggle to write legibly with the things that I have at my disposal at home. Okay, so as far as getting this, we're going to use our calculator. So you should have this free graphing calculator little computer app. Ms. Hall and I both have told you how to download that. If not, then you know your calculator will get, if you turn your phone sideways, that calculator will have sine and cosine. All right, so first of all, make sure that you are in degrees. Degrees. Okay. And then we can not do that. There we go. Okay, so then we can just type this in. So I want 7 sine of 105, close your parentheses, and then divided by sine of 35 degrees. And you get apparently twice. 11.788. So pay attention to what the directions say on where to round. As a general rule, we've been rounding to 3 decimal places because that's what the AP exam wants for those of you that are going to take calculus next year. So if you're not told, when in doubt, give me 3 decimal places. If your directions tell you, then you can go with that. And I literally just forgot that fast. 11.788. All right, so side C is 788? Y'all for real? Yes, okay. All right, so next example, we're going to find angle B. All right, so if we set it up the way that I generally do, I just always remember the formula the same way. If you want to set it up the other way, that's fine. So we're looking for angle B. So I need to know side B. So 4.7 over sine of B is going to be equal to, and then this is the matching pair that I have that makes it okay for me to use the law of sines. 5.5 over sine of 63. All right, so when I cross multiply, we get 4.7 sine of 63 is equal to 5.5 sine of B. All right, so we're going to divide by the 5.5. All right, so then my goal is to get the angle. So if you watched the videos and did the work from last week, then you know that to find an angle, we're going to do the inverse sine of both sides. So that means to find angle B, what's going to go in our calculator is inverse sine. Have mercy. I have to remember to pick my pen up like way high off of this little tablet, or it just runs all of my stuff together, and I don't always remember to do that. Okay, so we're going to do inverse sine of all of this. All right, so in my calculator, we are going to do inverse sine, so second sine, and then we want 4.7 sine of 63 degrees divided by 5.5, and then close parentheses on the whole thing. Make sure you don't put extra closed parentheses in there. You want it to figure out all of this and then do the inverse sine. So we get 49.588. And that was an angle, so degrees. Okay, so those are examples of if I'm just looking for one piece of information. So our next 2 examples are, can you solve the entire triangle? And the way that I set this up is kind of the reason that I use the formula the same way every time. If I'm asked to solve a triangle, then I'm going to go ahead and label that I don't know side A, I don't know side B, but I know that side C is 12. I know angle A is 45 degrees. I know angle B, I don't know angle B, sorry. I know angle C is 20 degrees. All right, so I am trying to find these 3 pieces of information. So I want to know this, I want to know this, and I want to know this. All right, so looking at what I have, I can see my matching pair is the C's. So I can start with saying 12 divided by sine of 20 degrees is equal to, and then here I know one thing and I don't know the other, so that's what we're going to go with finding first. So A divided by sine of 45 degrees. All right, so if we cross multiply, we're going to have A sine 20 degrees is equal to 12 sine of 45 degrees. And then we divide. All right, so then we go to our calculator and we type that in. So we have 12 sine, only one sine, of 45, close parentheses, divided by sine of 20. So we get 24.809. No, really. Okay, 24.809. Is our side A. Sorry, 24.809. All right, so now we need to figure out how we're going to go about getting these B values. Well, first of all, remember that if you know two angles of a triangle, you can find the third one because the angles in a triangle add up to 180. So if I do 180 minus 45 minus 20, I can get angle B. Okay, I probably should have thought that out better. We'll go back and rewrite it. So angle B is equal to 180 minus 45 minus 20. So what is that? 160. So 105. Yeah, really. I'm going to grab a calculator because my brain is fried. Minus 45 minus 20. 115. See, I knew I was wrong. Okay. So then to find side B, we're going to set up something similar to what we did for side A. It's a good rule of thumb to try not to use these things that you found where you had to like round the decimals. So we're going to go back and use the fact that we know we were given both things from C. So we can set up 12 over sine of 20 is equal to, now we're looking for B over sine of 115 degrees. All right, so instead of writing all of this out like I did over here, I'm going to go with a little bit of a shortcut, and it's not really a shortcut. You're doing all the math. You're just not writing it all down. So I can say that I know B is equal to multiply the two that are across and divide by the lonely. So 12 sine of 115 over sine 20. If you need to write out every little step, that's really perfectly okay. I just like to write as little as possible. So again, multiply the two diagonal and divide by the other one. All right, so that's going to give me, let's see, 12 sine 15 of 115, not 15, sorry, divided by sine of 20. And that gives me 31.784 is side B. Okay, so you can always go back and look at your information. Like when I got this number, I was like, ooh, that's kind of big for a side. But if you look at it, I mean, this one's 24 and this one's 12, and then 115 is a pretty big angle compared to the other two. So it makes sense that it's that big. So we can put it in and we are done. So you have solved the entire triangle. All right, so one more example. All right, so again, this one we have triangle PQR. So we can say we know P is 10. We know Q is 14, and these are all sides. And we do not know R. All right, so then angle P is 39 degrees. Angle Q, we do not know. And angle R, we do not know. All right, so when you're looking at what do I find first, you start with your matching pair. That's always the first thing that you write down. So I'm going to come over here and say, I'm going to switch my colors up and see if that helps y'all follow along any. I think y'all should be fine, but we'll see if this helps. All right, so we have the matching pair, so 10 over sine of 39 degrees. And then you have to know one thing to find the other. So I cannot find anything to do with R right now because I don't know anything. But I do know a little q, so I can find a big Q. I know the side Q, so I can find angle Q. So we're going to say that this is equal to 14 over sine of Q. All right, so now we know we're going to cross multiply. All right, so same thing. I'm going to kind of skip a little bit of my steps. So I'm going to say sine of Q, because that's the thing that I don't know, is going to be equal to the two that are diagonal. So 14 sine 39 over 10. All right, and then remember to find the angle, you have to inverse sine. So I'm going to do the inverse sine of all of this in my calculator. Okay, I won't try to squeeze that in up there. I was going to, but that's going to be a hot mess. Okay, so we'll go back to, and I'll just write it. Okay, so we're going to inverse sine all of that. So here we go. So second sine, then 14 sine 39, close parentheses, divided by 10, close parentheses. And we get 61.769. So angle Q is 61.769 degrees. Okay, so next, what do we have that we can find? Well, I know these two angles, so I should be able to find the third angle in my triangle. So to find angle R, we're going to do 180 minus 39 minus 61.769. All right, so 180 minus 39. Okay. Minus 61.769. So what is that? 79.231. All right, so now what we have left is to find side R. And so this time we have to use this found information. We don't have a choice, but we can still go back to using the given for the matching pair. So we're going to set up that we want to do 10 divided by sine of 39 degrees is equal to R divided by sine of 79.231 degrees. All right, so working on solving that, we are trying to find R, and that should be equal to the two that are diagonal divided by the sine of 39 degrees. All right, so if you think about, if we cross multiply, you get 10 sine of 79.231 equals R sine 39. So we just divided the 39 to the other side. All right, so now in my calculator, I can do 10. Yo, this is making me nuts. Those of you that aren't used to me, I'm going to apologize for talking to myself. So let's see, 10 sine of 79.231. Close parentheses divided by sine of 39. And we get 15.610. All right, so back up here to finish filling in our information. Oh, is that what I just wrote? No, 6-1, not 1-6. Okay, so that is the law of sines. So if y'all have questions, make sure that you email me or Miss Hall or message us in Classroom. We're happy to help. If you need any of this explained, we're happy to re-explain it to you. If you need help when you start doing the quiz, we're happy to help with that. Make sure that you're asking those questions if you have them.